All right, class, welcome back to another math video. Go ahead and open up your books to page 411. We're going to do section 5.5 today, chapter 5, lesson 5, the Pythagorean theorem. This is one of my favorite topics. It's very practical. You see the Pythagorean theorem all over in real life. You know, whether it's building, whether it's design, or just wherever, you see the Pythagorean theorem. It's a huge part of one of the huge things that is used in our world for different things. So first thing we notice is we come across two different vocab words here. It says a right triangle, and this is important. Pythagorean theorem is not for any triangle. It's only for right triangles. So go ahead and underline that. Is a triangle with one right angle. Okay. So as you can see from our picture here, this is a right triangle. Our right triangle, we know it's a right triangle because this corner here makes a 90-degree angle, okay? That means it's right if it makes 90 degree, and that box tells us it's 90 degrees, okay? Now if we look here, it says the legs are the sides that form the right angle. So the legs, we have three different sides here, side 1, side 2, side 3. The legs are the two that are connected to the box. So here we have leg 1, here we have leg 2, okay? It says the hypotenuse is the side opposite the right angle. So the hypotenuse, kind of a funny word, is the one across from the 90 degrees right here. Okay, so it's almost like pointing an arrow to the hypotenuse. These two are legs. That's the hypotenuse. The hypotenuse. Fact here, interesting fact. The hypotenuse will always be the longest side. Okay, so no matter what this side is and what this side is, this one will always, in every situation, if it's a right triangle, this side will always be the longest. So it says draw a right angle symbol in the right triangle, which we did right here already. Then it wants us to measure the sides in centimeters. So I got my ruler here. I'm going to start this one at 0. So here we have side AB, BC, side BC right here, which is going to be 6 centimeters. Don't forget your units. Then over here we have side CA, which is 8 centimeters. And then we have side AB, that's our hypotenuse. It's going to be 10 centimeters. Okay, so we just measured those and we found that out. We're going to maybe use that information later, we'll see. Then it says here, when viewed from the side, the shape of a wooden water skiing ramp is a right triangle. So, you know, here we have a water skier guy or boogie board or whatever it is that that person's doing. And usually, you know, you have a ramp, you know, here's your water. Then the ramp, you know, is up in the water that they shoot off of. And you have your little skier person here. And I know Mr. Neugebauer does amazing drawings. So, you know, your ski person here will go up the ramp. Well, this ramp here forms a right angle, okay? A lot of things are built with right angles. So it says, suppose the height of a ramp is 3 feet, the length or the base of the ramp is 4 feet. How long do you think the ramp will be? So what it's basically saying here in my picture is that the height, this side's 3 feet, the length is 4 feet, and if that's true, how long of a board or how long will the ramp be that the person's actually on? So right here, just make a guess about that. If it's 3 and 4, now remember the hypotenuse has to be the longest side. So just give that a guess, yes, and we'll talk about that in class tomorrow. Turn the page. Whole key to this chapter is this Pythagorean theorem. Now, on the page before I called this leg 1 and leg 2. These actually have letters that are associated with them. Side A and side B and side C. Side C is always the hypotenuse, okay? So I'm going to put a little H there. You go ahead and do that too. Side C is always the hypotenuse, okay? The one across from the 90-degree angle. Then A or B, I'm going to put little L's by these. You should probably do the same. A and B are always the legs. Also, I want you to do a little back and forth arrow. Like that, because A and B are fairly interchangeable. It doesn't really matter which one you have as A, which one you have as B. A lot of times we do B for the bottom one, for the base, but these are fairly interchangeable. Like, oh, if I have A, do I put it for A or do I put it for B? It doesn't matter. But C always has to be the hypotenuse, the H, okay? So, the Pythagorean theorem describes the relationship between the lengths of the legs and the hypotenuse, okay? You can use the Pythagorean theorem to find the length of a side of a right triangle when you know the other two. So using this formula, a squared plus b squared equals c squared, basically what it's saying is, if we know two of these, either a and c, or a and b, or b and c, if we know just two of these in a right triangle, we can always find the missing third side using the a squared plus b squared equals c squared Pythagorean theorem. So here's what we have here. We have right here 9 inches, 12 inches, and c inches. So right away we know this is the c side. This is the hypotenuse, okay? And then what we have are the two legs, A and B. So all your steps include is writing the formula first. And me and Miss Neal are going to be checking this. To show correct work, you write the formula. A squared plus b squared equals c squared. Then underneath you're going to hear us say, write what you know. Well, what do you know? I know A is 12. I know B is 9. Okay, you fill in what you know. Write what you know. We don't want you doing the math here all in one step. We want to see the formula. We want to see the two things that you know plugged in and the thing you don't know brought down. Notice I didn't put anything in for C because I don't know what it is. Then you square. Here, order of operations. You do exponents before you add. So 12 squared is 144. 9 squared is 81. So I bring those down. Then I bring my plus symbol down. Still don't know C. I add these together, and I get 225. Okay? Now 225 equals this c squared. Well, I want to find c, not just c squared. So how do you undo squaring a number? Well, you take a square root, which we've worked with before. So you take the square root of this number, and notice the square root got rid of the square. Okay, those cancel out. So I take the square root of 225, and I get c equals 15. Now, square roots are always a positive or negative, so it could also be negative 15. All right? So that's kind of how the Pythagorean theorem works there. So right here, we're going to jump over to example A. And we're going to do our work to the side over here. So for example A, I got to look here. What sides do I know? I know my A, I know my B, because those are connected to the 90-degree angle. I need to find my C. So up here, you first write the formula. This is for A. You write your formula. A squared plus B squared equals C squared. Okay? Then I plug in what I know. What I know down here is 24 is my A. So I write 24 squared. Plus I know my B, which is 18. So I do 18 squared equals, my C is the thing I don't know, so I just leave it as C squared. You need to write your work exactly like this. Then you can just take your calculator, and I do 24 squared. And that's now 576. Plus, I do 18 squared. That's 324 will equal C squared. Now I add these together. So 576 plus 324 gets me 900, which equals C squared. Now, here's how I'd like to show you work. To get rid of the square, you take a square root of both sides. Okay? Put the plus or minus over here, because it's either positive or negative. And then lightly cross out the square root here, and lightly cross out the square, because showing those cancel. So what you're left with is C equals whatever the square root of 900 is. So I take 900, square root it, oh actually I did that wrong. So square root 900, and I get 30. So C will equal 30, except it'll be a positive or negative 30. All right, that's your answer there. Box or circle it. Now, both these examples I showed you, you knew the A and the B. Well, look here. Here we know this side, and then we know this side. What we're missing is the B side, okay? So, oh, by the way, this one here, very important. There's units. Don't forget your units. I need my yards, YD. Okay, don't forget units. Now here, we don't know the B side. So still, same step. And this is why you write down the formula every time. You write the formula a squared plus b squared equals c squared, fill in what you know. Well, what do I know? I know I'm missing the b. So notice the b stays b. I know the other leg then must be a, which is 8, so I plug that in. Then I know the c is 24. Okay? So then I square them, just like I did before. I don't add first, don't do anything crazy. You square numbers. 24 squared is 576. 8 squared, 64. Okay? Now here you just solve like an equation. We want to find b. Well, what am I going to get rid of first? The exponent or the adding? I get rid of adding. How do I get rid of a positive 64? I subtract 64. So I subtract 64 over. My 64's cancel. I subtract 64 and I'm left with 512 equals b squared. Well, how do you get rid of squaring a number? The same way we did here. We just take a square root, and this little squiggly equal sign means approximately. Once you take the square root of 512, b will be approximately 22.6. Now look here at example B. Same idea. I know this is 3. I know that's 8, which is my C. What I don't know is my B. So just like before, I write down my formula first. A squared plus b squared equals c squared. Then I plug in what I know. Well, I know that b is going to stay b because I don't know it. I know the one across from the 90 degree angle is the hypotenuse, which is 8, then squared. I know this side must be a, the other leg, which is 3, and it is squared, because that's what the formula says. Then, just like before, I square the numbers. 3 squared, 3 times 3 is 9, plus b squared equals 8 squared. 8 times 8 is 64. All right? Now, a lot of people get stuck here. They do this and they're like, oh, I'm not sure what to do next. Remember, you're trying to find b. So we want to move everything that's on this side of the equation over. So do I get rid of the exponent or the positive 9 first? I get rid of the positive 9. How do I get rid of adding a positive 9? You subtract 9. So then you're left with b squared equals, then here if we do 64 minus 9, we get 55. Okay? Then I'm left with b squared. I don't want b squared, I want just b. So I take the square root of it, and then what I do the one side, I have to do the other, take the square root of the other side. Now remember, lightly cross out your square root, lightly cross out the square, they cancel, so I'm left with b equals, I take the square root of 55, which is 7.41. My directions here didn't really tell me where to round, so I take the 7.41 and I need to do little squiggly equal signs. So b is approximately, round to the nearest tenth, 7.4. Okay? And don't forget your unit with these mi for miles, all right? Important you don't forget your units. I now want you to work out c on your own and put your answer in here. Do your work underneath, all right? So the converse, if you reverse the parts of the Pythagorean theorem formed, it's called the converse, okay? So converse of the Pythagorean theorem is also true. So here's the statement: a squared plus b squared equals c squared. Then a squared plus b squared equals c squared. Then the triangle must be a right triangle. So basically all it's saying is, if a triangle is a right triangle, this will be true. So if it's a right triangle, this will be true. The converse is then, if this is true, it must be a right triangle. It's just kind of like two sides to the same coin. Okay? Now, last example. Look here. It says the measure of 3 sides of a triangle are 5 inches. Okay? 12 inches and 13 inches. Determine whether the triangle is a right triangle. This goes to the converse. Meaning, It's a right triangle if a squared plus b squared does equal c squared. Okay, so I'm trying to prove if this is a right triangle. If it's a right triangle, if I take the a and the b and square them and then add, it will equal whatever c squared is. If it doesn't equal c squared, it's not a right triangle. So I look here, and my sides are 5, 12, and 13. Well, how do you know which one's A, B, and C? Well, A and B are interchangeable like we talked about before. It doesn't really matter which one's A, which one's B. But we do know C always has to be the longest. Which one's the longest? 13, so that has to be the C. So what I have is I take A for 5, B for 12, C's 13, square them, add them, and what we find out when we do that is that 169 equals 169, which means it is a right triangle. If you were to get something like 180 equals 169 when you do this, it would not be a right triangle because a squared plus b squared did not equal c squared. So let's look at D here. Here are our sides, 36, 48, and 60. So you write your formula first. A squared plus b squared equals c squared. I plug it in. My biggest side has to be c, so I'm going to plug that in. 60 squared. Then these are a and b, so 36 squared plus 48 squared. You have to show all of your work writing it down. So I take my calculator, I do 36 squared. That equals 1296 plus, then I do 48 squared, 2304, 2304, equals then 60 squared, 3600, which means when I add these other two numbers up, they should equal 3600. If they don't, it's not a right triangle. If they do equal that, it is a right triangle. So let's find out. So I do 1296 for that, plus 2304 for that. We get 3600, so it is a right triangle. All right? All right, if you have any questions, come with them to class tomorrow. See you guys then. Have a great night.